Hello, my name is Jason Chanko and I'm the Applications Marketing Manager for SIGLENT Technologies North America. And this is part 2 of the SDS5000X feature introduction video. I would like to talk a little bit more about the cycle-to-cycle jitter and other measurement statistics that we have on the new 5000 series. In this case, I have a square wave on channel 1, and this is being built or generated by one of our generators. I'm also going to add channel 2. Here, we'll just do this that way. And channel 2 is slightly more jittery, and I've done that programmatically using a different circuit or different technique with our waveform generator. Now I'd like to test what the cycle-to-cycle jitter is between these two channels. I can go to Measure, Custom, and then go to Clear, and I'll set up Type. Now I'm on channel 1, and now I'll set up the horizontal cycle-to-cycle jitter, or CCJ. So that's going to be any cycle-to-cycle jitter for channel 1. Now I want to do the same for channel 2. So source channel 2, cycle-to-cycle jitter, close that off. And now I'd like to take a look at the statistics for these, as well as the histogram. And so over time I'm going to fill up the histogram, and you'll see that that's not exactly what I wanted to do. So this is the cycle-to-cycle jitter histogram for channel 1. You'll notice it's fairly even distribution, but if we look at the pink channel 2, you'll see there are separate bins that are being divided here. And what's happening is the cycle-to-cycle jitter for this particular channel is very, very deterministic. It has 3 bins that it can go into. Basically, the jitter is quantized and going to, and that's very easy to see as we start to collect those statistics. Every once in a while, we're getting a bin over here with the jitter or the rise time, and then we get the rise time here. So the cycle time, the jitter is actually fluctuating between these two. Very, very easy way to take a quick look. We'll let the clock run for a period of time, and then we could see, does the clock have some kind of deterministic or quantized jitter? The next function that I would like to explain in more detail is the search function. The search function is very similar to a secondary set of trigger conditions that we want to apply to a collected set of data. In order to visualize that, I've got that PRBS or pseudo-random bit sequence that I'm going through again. Now I'm going to select single just to freeze the image on the display and freeze that data in memory. I'm going to go up to analysis and hit search. Now you'll notice that all of these small white triangles have appeared. What we can do with the search function, I'll go back here and show you the trigger menu. So we've used an edge trigger to acquire a set of data, and now we're going to go back to the search algorithm, hit the setup menu, and now you'll see that we've selected pulse as the mode. On source 1, we've selected a polarity and limit range with an upper value. Now this new set of conditions are going to be applied across the collected data set, and it's going to indicate each of the condition or each of the locations where that condition has been met. Sort of like a secondary trigger that's going to point out different trigger events to us, secondary trigger events or search results in this collected set of data. Again, we can see all of those. If we made the data set larger, we could also look through more data, and now we can shrink in and we can actually go to one key navigate, and that's going to get us the event number. So we can actually sequence through each individual event, or we can fast forward and rewind through those events as well as pause. And we can change that search event to go by time as well if we wanted to just look at time elapsed from the trigger event. So again, the search event can be very useful if you're looking through large data sets. We also have, similar to the search event, we've got a history function. History function is going to take successive frames of data and show those individual frames very much like a movie. And we also have the ability to perform mask tests. We can set up a mask on the display and it can give us a pass or a fail. And we can also take a look at the navigate. So again, we're going to just pop through different events here and be able to search through each of those. Now I would like to introduce the waveform histogram function of the SDS5000. In this case, I've got a stair step output here using the signal generator. And so to enable waveform histogram is going to give you an analysis of the bins that have been hit, or the pixels that have been occupied by a particular waveform or series of waveforms. So we want to press analysis to open up that menu. We're going to go to histogram. And after we go to histogram, we are going to set the region. Oh, actually, I'm going to go back. I'm going to set this to vertical because it's more interesting. Go to region setting. Now I'm going to select X, and you'll see a small yellow box come out here, a small yellow line that denotes that X-axis. Now let's go to the Y, and you'll see as I start to go up, so at each individual bin location, we're going to get some statistics based on its location. So we can move that around, and we can now tell how often these values are getting hit. You'll see these pixels are going to have a lot more hit functions or statistical hits here in those bins than something up here. And we'll get a much smaller run here. We can actually move that around anywhere we would like. And we can, oops, there we go. Kind of grab onto two of those and we'll see the statistics. So we can actually take a look. If we had an event that occurred infrequently, we would see one or two small bins here. If we had jitter or some type of mistake in our pulse, we'd be able to acquire that information very quickly from the display. And again, we can use horizontal as well as vertical in this case. And now I'd like to take a closer look at some of the other features of the SDS5000. Just give you a quick rundown. Don't want to take up too much of your time, but we do have decoding. In this case, we've got standard decoding of I2C, SPI, UART, CAN, and LIN. Those are all included with the instrument. Those are free. And then optionally, we currently have available FlexRay, CAN FD, I2S, and then MIL standard 1553B. Those are available separately for your decoding options. We also have digital channels. So there's a pod here that would be inserted to give you digital channels 0 through 15, so 16 total digital channels. You could see those available here. Those can each be individually labeled as well for your mixed signal applications. Now I'd like to show you the LAN web browser connectivity with the SDS5000X. So I've connected a LAN cable to the instrument and connected it to our network here. I'm going to type in the IP address in a window here, the address bar, and after I've typed that in, I'm going to hit enter, and now we will come to the welcome page that is going to show us a number of configuration settings and the instrument control panel. When we open the instrument control panel, we're going to see exactly what we have on the display. You'll note that the cursor now activates many of our menu settings that we would normally press with our finger. Here we can get rid of the menu, we can move traces, we can add channels. Here we're going to just add channel 2. Now we can also capture screenshots, waveform data, and then we can convert the waveform data, which is binary, to a CSV using an internal tool. We can also perform firmware updates and expand that view to fill up the full screen. So in this way we can very quickly use the oscilloscope as a projector and project the image available. We also have digital voltmeter capability, so we're just going to press analysis, turn on DVM, and the digital voltmeter, we can measure a number of standard digital voltmeter functions, and we can also enable auto ranging as well as a bar graph, a histogram, and trending, and DMM hold if we want to. So all of these capabilities are included with the SDS5X. Again, really the options are the mixed signal, a external waveform or wave function generator, and then the specialized serial decoding. All of this starts at around $2,400 US for the 350 megahertz 2-channel model. The 1 gigahertz 4-channel model is around $7,000 US, 7,500 or so, depending on tax and shipping and that type of thing. So if you have any further questions about the SDS5X or any of the measurements that we've shown today, please drop us a line. Contact your nearest SIGLENT office, and we'd love to have a conversation with you. Thank you very much, and have a great day.